welcome back. We have today 1266 minimum time visiting all points. In this problem, we are given some set of points. Each set of points represents a point in our graph, and we are supposed to traverse those points in order. So we must start at 1, 1, next go to 3, 4, and then only go to 1, 0. If 1, 1 is here, 3, 4 is here, and negative 1, 0 is here, we can't just go to the closer one first. We must go in order. And each movement, whether we go up or down, so whether we go horizontally, sideways, or vertically up and down, or diagonally, each of those movements is considered one step, or they take 1 second. Okay, so the main thing, or the main idea here is to understand that we really only care about whatever is the maximum distance going vertically or horizontally. And I'll try to demonstrate here. So let's say we're trying to get to this point, okay? So whatever it is, we need to go right 1, 2, 3 times. And then we do need to go up as well, but 3 is larger than 1. And the idea is whenever we make one movement, we can go right or up or diagonally. So the diagonal movement can be built in. If we go 1 here, we can assume that we can also move up 1. We can go 1 here, 1 here, and the upwards movement is already included. And then if that wasn't clear, let's try with this. So we move right twice, right? So we make horizontal movements times 2. We make vertical movements 1, 2, 3. Okay? Now, if we say that it's 2, then we can go diagonally once, twice, but we're left with 1. And that's because whether our movement is diagonal, like so, or straight, like either of these, we still have to get through it. We still have to get to the correct floor. So the last example, let's do with this. Whatever it is, the upwards movement or the sideways movement is given for free. However, that distance we still need to cover. So this is 1, 2, 3, 4. That's 4. That's 1, 2, 3. That's 3. Whatever it is, we still need to cross this distance. So even if we make the best movement going diagonal, 1, diagonal 2, diagonal 3, we still need to cross the entire 4 distance. In this case, horizontally. So that's 1 more movement. So in each step, we just take the maximum of the horizontal distance or the vertical distance, and any diagonal movements are on the house, free. Okay, so let's translate this into code. So each time, or seconds, each movement equals 1 time. We start at 0, and we want to traverse every set of points. So let's say for I in range, we want to compare 2 at a time, and we want to compare all of it. Okay, so x1, y1 will be the first points. So I minus 1, since we're starting at 1, we're going to include these 2. And then x2, y2 is where we're trying to go, so that's 1. So at 0th index is where we're starting from, at I is where we're trying to go. In the next iteration, we will be going from here to here. And we say the horizontal distance is going to be the absolute, the distance between the two horizontal points. So in this case, 1 and 3. So x2 minus x1. And we do absolute because we don't care, we just want the distance in between. Okay? And then vertical is absolute of y2 minus y1. Once again, we don't really care which direction we're going, we just care about the distance. So vertical distance is, in this case, 1 versus 4. So we're starting here and we're getting to 4, that's 1, 2, 3. And remember, we're adding to time whatever is the maximum of moving sideways or moving vertically. And once we have that, we return time. And this runs in O of n time. It does run linearly, and O of 1 space because we're really only using constant variables. Let's submit. And there you have it. That was once again 1266 minimum time visiting all points. Thanks so much. Happy coding. See you next time.